So problem 30 is digit fifth powers. Now what we're going to do here is find the sum of all numbers that can be written as the sum of fifth powers of their digits. So for example with fourth powers, it gives the example that these four numbers here, when taking the power 4, like the digits, add them together, you get the actual numbers. So it doesn't tell us that there's a cap, so in theory you would have to search every single number, but if you look at it and do a bit of realising what it's doing, fourth power numbers, in this case like 9 to the power 4 is it's going to be something along the lines of like 6,500, something like that. So basically a fourth power number, let's say, equals like never more than 7,000, then a fourth power number can never equal more than 7,000, so 4 of them would be 28,000. Now 28,000 obviously means you can add them together and get any number, any 4-digit number in theory. This is going to be complicated, but basically if there's a 5-digit number, so you need to get add 5 digits together, that's going to be, instead of 28,000, it's going to be 35,000. So you'd have to check basically all the numbers up to 35,000 to make sure you'd got every single one. I'm pretty certain that is this right? Just quickly bring up a calculator. Okay, so yeah, basically the idea is that we do have a limit, even though it doesn't tell us there's a limit, we do have one, which is important because we're going to loop over all these numbers and add them together, sort of like brute forcing it. So for fifth powers, 9 to the power 5 is going to be, I should probably do this on a calculator so we get it right. So 59,000, so just below 60,000. So if we check, like I'm pretty sure all the numbers that can be written as the sum of fifth powers will be 5 digits long. Not sure why I think that, but I'm pretty sure it will be the case. But what we're going to do is check all the numbers, and because now we know 60,000 is the maximum that 9 to the power 5 can equal, we're going to say if we times that by 5, so say we've got 5 9s, yeah, so you can actually have your limit smaller than this, pretty certain, because you're not going to have 5 9s, the most you're going to be able to have is 4 9s and then say 1, because you could have like 1, so you could have like 19,999, some of those digits would be awesome. But basically the number I've got now is just under 300,000, so if we check every number up to 300,000 for this property, we can be certain we've got them all. This is a really long-winded explanation of why this works, but it does. So, well, I'm pretty sure it does. I haven't done this question yet, but I guess we'll find out. That was an awful explanation, but yeah, basically we're going to say our cap is equal to 300,000. For those of you that don't know, in the new Pythons you can add like a underscore to separate out your digits. Like if I just print cap here, just makes them a bit more readable. I'll print cap and call from 30. You see we've got 300,000, there's no underscore there. So yeah, just helps with the readability of big numbers. So what we're going to do is we're going to say for number in cap, range cap, we're going to say string of number equals string conversion of number, and then we're going to say so we're going to need a list to keep track of list of we're going to say valid numbers, and call them valid ones that are actually, well, ones that have this property. So we're going to say total equals 0. We're going to say for digit in string number, total plus equals digit to the power of 5 if total is equal to the number. Then we want to add our number to our list, so list of valid numbers dot append number. Then at the end we want to print out the sum of the list. So that there should give us the answer. Hopefully this doesn't take too long to run. I'd imagine it will, because this is quite a big number. But what I'll do is I'll start off and then explain what I've been doing. So I need to, for digit, I need to call it an int right here, because it's obviously a string coming into it. Okay, it didn't take actually that long to run, but basically what it's doing, it loops over 300,000 up here. For each number below 300,000, it converts it to a string, and then keeps track of a running total. This run total is going to be the sum of the power of the digits. So then it says for each digit in the string. So this obviously, say the number is 100, this will take the 1, then the 0, then the 0, and it'll say for this running total, add to it the int version of this digit. So in case of like 100, it would be take 1, convert it to an int, so make it actually 1, not the string 1. Put it to the power 5. At the end, once we've got our total looping over here, we say if our total from the digits is equal to our number, then it passes our test, and therefore we're going to add it to our list. And at the end, we sum up the list, so however many we've got, and print it. So let's check if this answer is right. So we've got 443,840. So let me refresh just in case the capture code's timed out. So 443,840 confirmation code, and I got it wrong. Okay. Interesting. So maybe my limit is wrong. Let me just double check this on a calculator. So we got 9 to the power 5, and then we've got a possible, so we're doing 6-digit numbers, so we times it by 6. Okay, so I think I'm going to go up to 355,000 here. I'm pretty sure I just got the limit wrong. I think this should work. Just to show what I did, I've actually just changed the cap to 355,000. No, the number's still the same. Let's do all the numbers up to 1 million. Perhaps I was wrong with the whole cap idea. I don't think I was though. See, we're not actually finding any new ones now. And if I print out this list, I'm pretty sure they're all going to be 5 digits long. Ah, okay. So the problem is, in this thing here, it says that 1 does not count because it's not a sum. And when I'm summing this list, it's included 1. So you can see these are all underneath the original cap that I had in mind. They're not actually all 5 digits long though, which is interesting, but yeah. So I just need to take away 1 from the answer it gives. So let's go back over here, try this with 39. There we go. So yeah, obviously when you don't have the actual answer there, it's quite difficult to see what your problem is, but quite often if you just print out your variables like I just did when I printed the list, quite often you just see like little daft mistakes like carrying the 1 when I shouldn't have been. So I suppose I could just like drop the 1, but it's really not worth doing, I don't think. I'm just going to drop this cap back down to like 360,000, just to keep it reasonably small. So yeah, there we go, it doesn't take too long to run. So yeah, that's it from 30. Hopefully it helped if anyone's stuck with that or whatever. It wasn't too difficult, obviously a little bit of a trick with that 1. So yeah, thanks for watching, I'll see you in the next video.